mafia don, a gangster rap star, and a rocket scientist converge in a hospital room to ponder the meaning of life. The rocket scientist expounds Heisenberg's principle of disambiguation, otherwise known as the uncertainty principle, to which the three then sit in silence for a moment. And then the rapper says, "I'm down with that. Everything is everything, yo." This is not a joke. This was an episode of The Sopranos. But it's the first thing I thought of when Dave contacted me, about this conference, and I saw, the design of everything. Everything is everything, yo. The second thing I thought of was one of my favorite German words after Schadenfreude is Gesamtkunstwerk, a term that Wagner loved starting around the 1840s. This whole concept that the Teutonic world was very interested in the 19th century of jointly performed art production. We can say it's a total artwork, but that's kind of a cheap translation of it because Werke is actually also production as an industry, and Gesamt means complete as well as unified or cooperative. The Gesamtkunstwerk is probably one of the better ways of framing what it is that I'm trying to do, which, much like Sanat, involves trying to find or seeking to exercise practical applications for pretty big theoretical ideas. To my mind, this is the Gesamtkunstwerk that we know best. Who did it? We don't know. How? We don't know. How it all really works? We don't really know. But all the separate pieces of this planet that is our mothership work together in ways that are extraordinarily complex, and that we know even the slightest failure in interaction, to an extent, can be self-healing, but after a while can really have all kinds of unintended consequences. If we are collectively going to turn around the juggernaut of climate change that we're on, and I don't really think that if the Pentagon has something on its list of #1 national security priorities for the 21st century, that it can possibly really be in question anymore, then we have got to figure out how to understand better how total closed-loop systems, complex interactions work, and really apply them in design. So, architects early on, back when the Romans were eating their own very tasty food, were thought to be people who actually got to do pretty complete pieces of work. Architects were also engineers, they were machine builders, as well as people defining aesthetics and structures. Certainly when one starts to engage in space architecture, you're well beyond the framework of anything that is reasonably taught in school, and you have to be prepared to embrace the total society of engineers and scientists and operations people with whom you either work or you don't at all. So the basis for what I'm working through with this Gesamtkunstwerk talk, you guys are test subjects on this, but it's okay, it's coming along, is really about 5 main areas for the applied design principles that involve metabolism, power, materials, structures, and the human realm, the human interaction. These all are part of what I call the Mothership Idea, a sort of fundamental premise that this planet is everything that we struggle with, that we learn from, that we've evolved as part of, that we aspire to, that we imagine, that we poeticize, and that we still fail miserably in many ways to understand. But in even the smallest maneuver, like choice of product based on packaging, right? I mean, these are little things that you can do, but if you understand that those things matter and that they add up, then that's a little part of what I'm talking about. The question is, what's our Sputnik moment, right? What is going to make us all decide to get behind a big maneuver to change the way that we work, to change our own collective behavior? What is going to intervene to, God forbid in a negative way, to encourage that anymore? Maybe it won't happen. Maybe there won't be a Sputnik moment. And if there isn't, then we have to be prepared to move on our own. So the first basic principle then that I'm going to share with you is about metabolism. 12 of the 15 years that I spent working at NASA, I worked, and this is all mixed up, not all in one chunk, on this little project. It's a little house, really not a very big house, 6 rooms. It's about 250 miles up, and it's moving at 9 kilometers a second. And it is, I think, in pretty absolute terms, possibly the greatest human achievement of all time, in that 15 different nations invested non-military money, billions of dollars, in cooperatively building and in maintaining and operating a science platform in space. There are 3 people aboard it at any moment in time, and they're doing it right now. And every night, if you go to spaceweather.com, you can see when is there going to be a flyby in your zip code, and you can go out at night and see it. Man, that thing is huge, and it clocks across the sky really fast, and there's no mistaking it when you see it. It's also a closed-loop system, like the planet. And unlike the planet, it is a limited-scale, closed-loop system with complete situational awareness, right? We are studying every aspect of what goes into and out of that space station at any moment in time. There are hundreds of people in 4 different centers around the planet, full-time, watching what is happening in all the systems on this space station, what's going on with the astronauts, what is your gas balance and your liquid balance, and how is the life support regeneration system working. So we're learning things that the planet is simply too big and complex for us really to break down well. I've worked with people who are in biosphere too. Man, that was a complex project that they undertook, and it's a pity that people make such fun of the outcome because they really got a lot of science done there. But with the International Space Station, we can quantify it better. So the idea of metabolism is a cyclical exchange of energy, right? Everything metabolizes, and the interchange that metabolism represents is actually one of the most fundamental things of life as we know it. Balancing metabolic rates and metabolic systems is essential to our being able to maintain anything in a robust way. Bioregenerative life support, in other words, biologically based metabolic functions, were already identified a decade or more ago by NASA as the most robust potential way to set up, for example, a Mars expedition, because the crew would have to spend 3 years on the surface of Mars. There's no way you can send 3 years worth of oxygen, right? 3 years worth of water. And how do you accommodate 3 years worth of trash? 3 years worth of underwear? Well, that's still kind of an open loop question. These are advanced test beds for bioregenerative life support systems, some of which the Europeans have already brought, for example, the bioregenerative water cleansing system to 100% closure. They've been running at their Concordia station at the South Pole for several years now, and it works very well. And of course, the air exchange is also tied in with solid nutrient exchange, right? You grow food plants and then exchange those nutrients further down the bioreactor line. I put together a project a few years ago with the senior water policy advisor at the UNDP that we called Water for Two Worlds, in which we sought to work with the European Space Agency, NASA, and some NGOs in developing just a kitchen countertop or dirt floor of the hut top container of specialized bacteria that can be developed locally in many developing southern economy areas in order just to make sure that there's potable water in the household. Not a lot, but just enough that people can not get sick every day. This was something that, because I realized one day I was given a really great presentation about the MDGs and realized a lot of the stuff that we were doing at NASA for Mars exploration, in fact, would help to support the Millennium Development Goals. And that's just the first one of them that's been out there now. The whole water cleansing thing is light years ahead of where it was 5 years ago when we did this, and that's really good news. Power is the second. Now, the interesting thing about power is that it's the only thing this planet is not closed loop on. In fact, this is what we get for free. This is a big deal. We get so much free energy that we're in fact lucky to have a really strong magnetosphere to bounce off the worst of it, or we wouldn't be here at all. We would be fried, okay? So it's insane for us to be digging things out or engaging in the kinds of complex chemistry that we engage in order to fuel our fires at night, when, in fact, there's a huge amount of power coming at us, and we just need to figure out how to harness it properly. And from 90,000 feet, this is just simply something we have to buckle up and do. This image is a sunset on Mars on Midsummer's Day. That was taken from one of our first rovers out there. This relates to one of the projects that I've been working on, and actually Senna and I were talking about maybe working up some collaborative grant proposals. So this is one great thing from the Cusp conference so far. Development of passive houses. The passive house movement has been going on for a while. One of the challenges, though, is that if you really develop a completely passive house, the air is really, really tight. You then have problems with ventilation, with chemistry in the house. And while they're reasonable to build in Europe, where people expect that every house will be built for 200, 300 years, in the United States, the price point is simply constraining. So what we're trying to do with House is find ways of developing zero-energy residences that are affordable at a reasonable price point for the average American, using natural gas-powered, which is a start, trigen systems. We then capture the waste heat, right, which is in fact about 2/3 of the output of any one of these engines is actually thermal. It's not electricity. We develop electricity to support the house, but then in fact we can both heat and cool the house through a radiant loop that doesn't cost us any electricity at all because it's a byproduct of the energy making part of the cell. And then all of the electricity the cell produces we sell back to the power grid, which makes it a reasonable business case. And this is the challenge, is making these big ideas practical and palatable and elegant such that they are easily adopted. The third big principle with which I'm working to translate the studies that we've done for spaceflight is about the human interaction. What is it that we need? I find it funny when people talk about, going into space where one would be liberated. We didn't evolve in space. We evolved here. And we're really unhappy without most of the fundamental constituents of the planet, including, most importantly, the gravity vector. And learning to design environments that are operational and easy and functional to use for people who are not working in gravity is extremely challenging, much more so than one might imagine. But I was able, through a few years of working with various different researchers, to identify, to me at least, it cooks down to a sense of time, a sense of place, and a sense of wellness. Now, what each of those things means may vary. On the space station, the sense of time is a crucial one to one's well-being because you orbit the planet 16 times a day. That's a whole lot of sunrises and sunsets, and they're beautiful. And after 3 or 4 days, you're going crazy because you don't know when to sleep. Your circadian rhythm is totally shot. So, let's see, 14 years ago, a good 7 years before the first commercial patent was written for this, I worked with a team of electrical engineers that developed an LED-based array for a light fixture for the International Space Station. And that's one of those things, you work for NASA, you can't file patents on any of your work. So, but I'm not bitter. Much. Using things that DJs at every rave do now, but what we were talking about doing was shifting the color in the lighting system on the space station just enough that over a reasonable 12-hour daytime period, you would have shift from morning to noon to evening light, and then you would take them into their sleep period with at least a little more subliminal sense of support for the circadian rhythm. A sense of place. This is something we started having to do with zero gravity, which is put these avatars into agent-based models and identify really how much room the body needs to do this job without sticking your elbow through a wall. Can you fit in the airlock and put on the helmet and do this and pull the boots? And you know what? We don't do that when we're designing bathrooms. We don't do that when we're designing kitchens. As I'm sure some of you know, we've all run into situations where in my hotel room, the door to the bathroom is here, and then there's a thing. And of course, I don't hurt myself because I see the door, and I'm not going to intentionally run into the door, but I would if I didn't. So applying principles like that to the design of everything, just being a little bit more cognizant of the way these things fit together, basic dimensional requirements, and the basic ideas of choreography and programming. The proper relationship between different spaces, not only in terms of how the systems are delivering. In other words, you want your heavily ventilated rooms closer together. It makes it a less expensive air handling system, right? But do you necessarily want them closer together in terms of functionality? Do you want the bathroom right next to the kitchen? Maybe around a wall, right? One of the things I had to do, for example, was design the protocol for how An astronaut who was rendered unconscious would be carried from one module into another in the International Space Station, because we just hadn't thought about it. And one of the problems in microgravity is you grab whatever you've got and you go sailing through, and the chances that someone's head would just get whacked against a piece of equipment were really high. So not something you want to do when you're getting ready to perform CPR. And applying those ideas to other design projects is not as obvious yet, but I'm sure it will come to me. The sense of wellness is perhaps the most elusive, but it's an area where designers, decorators, and of course health and wellness experts love to talk. And I think that there's a science there, we just haven't really figured out what it is. Can we all understand about beauty, about light, about harmony and color? And really there isn't that much discussion about what is beautiful. When something really is, it's pretty transcultural in most cases. These were kitchens and bathrooms and stairways and hallways that we've done for House and other clients, playing off of some ideas that we developed, for example, when developing a pattern in a non-off-gassing material, using the colors that were available from DuPont at the time to help establish a sense of local vertical. Because, obviously in microgravity, up and down don't mean anything except that they really do, and we need them to, and we don't feel that. And visual cues, wherever one can build them in to a system like this, are extremely useful and very cost efficient. So materials. Advanced research into materials is, I think, one of the most essential things. What I find interesting is that the further along we go in developing new materials and looking at what's sustainable in the long run, the closer we get to the stuff that our great-great-grandparents used. Plastics, for example, are already coming pretty hard rudder, full circle, back to things based in plant matter, right? The cornstarch-based resins. You'll find a lot of plastics are called something like eco-plastic or Matière B. There's several different basic brands of the resin. They've been around for about 10 or 15 years, but they've really caught on in market acceptance in the past few. And that's helpful when one is designing a passive house. You have, less than 1% of one full air exchange per hour by accident in the house. So we definitely have to force ventilation in the house to move the air around. But God forbid you should build this house using paint and gypboard epoxy and glue for the kitchen countertop from Home Depot, because you will have headaches and nausea for the next year and a half, if not more. If anybody in your family is asthmatic, you really have a problem, right? So one of the important things about moving into the passive house area is that it enables me to reach out to people I've wanted to work with for a long time, whom I admire, who've been developing these no VOC products or better balanced materials and products, and form partnerships with them. Materials is something that we've actually learned a lot more about from NASA than most people are aware. On Columbia's last mission, STS-107, I helped to support 52 of the 80 science payloads that were performed during the 16 days of that flight. They included the regrowth of a moss that had flown already once. It was supposed to demonstrate chaos, randomness, some kind of pattern of randomness, because it was thought to grow away from the gravity vector. Instead, it had formed a perfect spiral, and it did it again. So guess what? Randomness is bullshit. I'm pretty much convinced of that anyway. I think that if anything really looks like it's chaos or it looks random, it just means that we haven't managed to jump scale far enough back to see its context and what pattern it's really forming. The Earth isn't flat. Hello. Other structures, crystalline structures, the structures of fluids and water, their fundamental properties are visible in microgravity in ways that they're not with the gravity vector on Earth. It's a powerful series of studies that are being done, and what their application is in advanced materials making is still actually proprietary to a lot of people. So I'm gonna back off on talking too much about it. But here's one example, various things that I've done with the spin-off company that I have for the pleasure of my heart. Vestigial Wings is where I'm making garments. All of these things are made using completely natural fibers, hand-dyed, bloomed, carded, whatever, wools, cottons, bamboo. The nest egg was a birdhouse project that we did using the cornstarch-based plastic. And there's a hospital bed that converts completely into a wheelchair. That was a more complicated, that's a more complicated project, but we got space certification for it because it was based on the seating for a spacecraft that I did. Structures. Interesting thing about structures. Architects, we like to draw and stuff, but we don't usually like the math quite that much. We can do it, but we don't love it. So structures professors in architecture school always have to struggle against a certain resistance to getting too complicated, right? So you've got compression and you've got tension. And basically all structures up until, last week practically, were compressive structures. Even arch action is a kind of delaying of the compressive force. Well, when you think about it, compression is just a response to the gravity vector, which is actually a dynamic vector, although it moves at the speed of light, so we don't really notice it's a dynamic. What that means, I don't actually know, so don't feel bad about that. But my buildings still stand up, so we're good. Basically, all structural force is tensile in nature. We just think that compression is the most important structural force because of the environment that we're in. Now, whether this brain flash is useful in developing and designing new products here on Earth for ordinary people is questionable, but I think the fact of knowing it helps to reset the context in which I'm thinking to solve problems and address design issues in ways that I frankly wouldn't want to go back to living without, so I don't really know. But here's another project doing the seat for the crew return vehicle, turning into the hospital bed. Structures. I remember working with TransHAB team. We were developing the world's very first inflatable spacecraft for human use. And I had this basket that my grandmother had given me that was woven by the Coshada Indians out of pine needles. And I'm sitting next to the structures guys who, condescended just barely to architects. It's our spacecraft. Don't mess with it. It's unusual for architects to take back seat to a structural engineer, but anyway, it was their spacecraft, really. They were the ones who were getting it funded. And they kept developing different versions of the weave for the pressure shell and the TransHAB. And they would put it in this enormous pool, the 60 million gallon pool that we have, and they would inflate it, and it had to pass 4 atmospheric differentials, so 54 psi. It kept blowing up, and then they finally came up with a weave that, damned if it didn't look exactly like that basket. And it worked. In fact, we broke the test stand. So that ticked off the people at the facility, but we passed our engineering chops. So the TransHAB program, very exciting. It was at the turn of the millennium, and it's still probably the best way to develop any kind of long-term human exploration missions. There are certain things that hard structures are good for and certain things that soft structures are good for, and when you work out a hybridization like TransHAB, there's a lot that you can do. We developed a concept for a commercial, more privately owned space station based on the same basic technology, and then for any advanced sorties to other planetary bodies in the near neighborhood, either a return engagement or something a little new. Also very useful because basically what you're delivering, your most expensive aspect of one of those missions is launching something from up the gravity well. Once it's up there, it's not a lot to send it to its destination, and it's not that much to land and maneuver it, but the smaller the object is between here and high Earth orbit makes a big, big difference. So having a smaller structure and then allowing the operable, usable spaces to be inflated outward makes a big difference. This is a concept of a sort of self-deploying vehicle. This was the Spaceport Terminal that we did with Norman Foster for Virgin Galactic. Pretty exciting. Foster's came in with this beautiful little glass shape. And, we're picturing putting it out there in the desert in New Mexico and going like, and you have a budget of just $90 million. You realize this, right? And we came with an Earth ship. And, their designer and I spent 24 hours intensively working together, and basically what we came up with was a good belly button. The omphalos is Greek for navel. And thinking about it in the big picture, developing a spaceport, you're sending people off from the planet. Now, these people are going to come right back, but someday they won't. And those are going to be really emotionally powerful and culturally powerful places. The place from which we departed the mothership, right? So without talking about it really necessarily in those terms with the engineers, I like to try and maintain an understanding of that aspect that we're working in. This is the image I wanted to leave you with of the Gesamtkunstwerk that I'm proudest of having worked on. This was taken during a solar transit of the space station with the Space Shuttle Atlantis still docked. And I just got chills the first time I saw it because I could imagine myself, and yes, I read too much science fiction, but I could imagine a visitor to our solar system popping in and seeing that and going, oh, there's company in the neighborhood. There's makers somewhere in this system. And I don't know where we're going and how we're going to maintain that and whether we're going to continue this forward movement. But this is the greatest thing that human beings have ever done. And we should be incredibly proud of it and not forget that it's there and continue moving forward. Thanks.